Hello guys, welcome to the episode 9 of System Design 100, and today we're going to talk about a very small topic. It's called queues, or specifically if I say it's called messaging queues. Okay. Uh, so uh, queues to explain queues, queues are mainly like the main use of queues is within the web tier of our particular architecture, and the reason queues are used I'll explain you in a minute. Okay, so I'll expand this web architecture, but what exactly is inside the web architecture we'll explain. Okay, so till now I have explained you like there are servers inside the web architecture that connect to that process user data, and then they connect to database, they pull database data into the user. But what exactly is happening inside a web server? In general terms, there are two kind of servers in web servers. We have something called as front-end servers. So this server is for front-end, that contains a front-end application which a user can see and interact with. And one, we have a back-end server. Okay. Now, but the job of backend server is to do very heavy work. Okay, a very big transformation in data, very huge data processing, and any kind of a very huge transformation that requires very that doesn't require any kind of front end, any kind of a user interaction. The batch processing kind of thing, any kind of processing that requires very huge amount of CPU and very high amount of processing. So backend servers do that, and the thing is that backend servers are the one which are connected with the databases. So you read and write. Generally, backend servers do read and write thing. Front-end servers talk to the user or load balancer, whoever is in front. Okay. Now, the data between front-end and backend is exchanged continuously, and whatever data user is interacting with is exchanged between front-end and backend. So whenever user tries to access some data or pushes some data, it goes to the front-end server. Front-end server does some kind of a little bit of processing that it does with the data, and then it sends the data to the backend, and then the backend stores the data into the databases. I'll just create it. That same database is there, right? Okay. Now, in this case, what happens is that this is a tightly coupled system. If I create a direct coupling between these two, no, this is a tight coupled system. Only when a front end, whenever a front end is processing something, the backend has to be ready to accept some data from front end. Then only this particular transaction will work. Okay. For example, backend is busy at that time, and if front end tries to send something, so the data will get lost because backend will not accept it, right? Because it's been busy in some other particular task. Now, so that in this case, what is there is that we have very tight coupling, and any kind of tight coupling is discouraged in a good architecture. Tight coupling generally leads to data losses, and it's not for it's not very good. It's not very good in terms of performance as well. Okay, so in this case, what we have, right? Every time backend needs to be available when front end is sending some data to backend, and same for front end. When backend is sending some data back to front end also needs to be available. It's not like if front end is, for example, is very heavily loaded, it is working on something else, and backend sends some data back. The data will be lost because this will not be able to receive the data since it's within something else. To fix this particular issue, we use something called queues. So queues are like of a, if you have read about there is a data structure called also called queue. So queue are a very simple data store which has a mechanism to accept data and to store it and to release it. Okay, so the use of queue in this case, how it can happen. For example, some data came to front end. Okay, now instead of sending that data directly to backend, what the front end will do, it will store that data into the queue. Okay, it will store it here. Now it doesn't matter if backend is busy or not. Our data is in queue now. Okay. For example, at this particular time, our backend is busy. So what will happen is that our data will not get lost. Instead, it will stay in the queue itself. When the backend is ready, now backend has completed all. Now it is ready to work with frontend. It will go in, instead of directly talking to frontend, it will go into the queue. It will check that if there is something data, it will see that there is a data present here. It will pick up that data and process it, and our data will get processed. It will not be immediate, definitely, but definitely our data will not get lost. Similarly, front end can keep pushing some data, and data can keep queuing up here one after another. Backend does not need to be available all the time just for the front end to work, and the front end needs not to be working every time just for the backend to process the data. Okay, we can establish an asynchronous relationship in which both of them are not in sync, even though no data is getting lost. In earlier example, they needs to be in sync to send and receive data, but this time we have removed that particular dependency. Okay, so this is one benefit. One other benefit, if I talk about, is that when we try to scale our systems. Okay, for example, we are getting a lot of users, and we are trying to scale our system. So we have added more servers for front end instead of one. I have added 2 or 3 depending upon that, and for backend I have added 2 servers. Now, which particular server will talk to which particular backend? It's an hassle. Okay, for each of the server, I have to define both of these backend servers into each of the servers so that the services can be routed to, and we have to have some kind of a monitoring system in which the servers can assess which server is busy and to which server we can send some data. So scaling is a very issue. Coupling between servers becomes an issue when we are sort of talking about scaling. But when we are using queue, we can simply connect the part that takes in data to the front end servers, and the part that accesses data to the back end servers. All of these servers simply can push their data into this queue, and all of these servers can simply take the data that is present in the queue. So again, we are saved from the hassle that each front end server should know about each back end server. And again, all of the data will get processed instead of getting lost. Doesn't matter which front end server receives the data from the user. It doesn't matter which backend data accepts the data to process it. Okay, so this is a very good example of why we technically use queues. Queues are not only used here; they are used in a lot of parts in system design. But it's one of the main uses is with the web tier. And okay, and there are multiple techniques we use. Right, there is something called FIFO, first in first out. So whichever data gets enters first in the queue, it will be the first one to be accessed by backend. FIFO, and I think first in last out. A lot of techniques are there depending upon the particular application requirement or particular use cases. We can define different kind of queuing techniques. Okay, so I think, yeah, this was it. This was episode 9. Thank you very much.